close your eyes for a moment. Think about your hand, the one resting on your desk or your lap or holding your phone right now. That hand is made of atoms, roughly 7 billion of them in your whole body. That's a 7 followed by 27 zeros. Each one of those atoms is ancient, and I don't mean old in the way your grandmother is old. I mean old in a way that breaks your sense of time entirely. The carbon in your knuckle? It was forged inside a dying star before our sun even existed. The iron in the blood flowing through your wrist was born in a supernova explosion, so violent it outshone an entire galaxy for a few weeks. The oxygen you just breathed in, it has been part of oceans, part of thunderstorms, part of dinosaur lungs, part of Roman soldiers, and now, just for a brief flicker of cosmological time, it is part of you. Now here's the question nobody wants to ask, but everyone quietly thinks about. What happens to all of those atoms, those ancient, traveled, storied atoms, when a human body is cremated? Do they die? Do they vanish? Does the fire destroy them? And if it doesn't, where do they go? This is not a morbid question. It is, in fact, one of the most beautiful questions in all of physics. And the man who perhaps understood its beauty better than anyone was Richard Feynman, the Nobel Prize-winning physicist who once said that if all of scientific knowledge were to be destroyed, and only one sentence could be passed on to the next generation, it should be this: all things are made of atoms, little particles that move around in perpetual motion, attracting each other when they are a little distance apart, but repelling upon being squeezed into one another. One sentence, and within it, the key to understanding not just cremation, not just death, but the entire architecture of reality. So today, we are going to follow your atoms, your actual, physical atoms, through the process of cremation, step by step, degree by degree. And by the end, I don't think you will look at fire or death or even yourself the same way again. Let's begin. Part 1. What you are, physically. Before we can talk about what happens to your atoms in cremation, we need to be brutally honest about what you are. Not who you are, not your identity, your memories, your dreams, but what you are, materially, physically, at the most fundamental level. You are a temporary arrangement. That's it. That is the physical truth of your body. You are roughly 60% oxygen, 18% carbon, 10% hydrogen, 3% nitrogen, and then a smattering of other elements: calcium in your bones, phosphorus in your DNA, iron in your blood, trace amounts of things like zinc, copper, selenium, even tiny amounts of gold. About 0.2 milligrams of gold, if you're curious. Not enough to sell, just enough to be poetic. Now, Feynman loved this idea. He was obsessed with it, actually. He found it hilarious and wonderful that a human being, this thing that writes poetry and falls in love and argues about politics, was, at bottom, just a collection of atoms obeying the laws of physics. Not because he thought humanity was meaningless. Quite the opposite. He thought it was astonishing that atoms, arranged in a particular way, could contemplate their own arrangement. Think about that. You are atoms that know they are atoms. But here's the critical thing. Feynman understood, and it's the foundation of everything that follows. Those atoms are not yours. They are not stamped with your name. They are not loyal to you. They were borrowed. Every atom in your body right now was somewhere else before you were born, and will be somewhere else after you die. You are like a wave in the ocean. The wave is real. You can see it, measure it, surf on it. But the water that makes up the wave is always changing. The wave is a pattern, not a thing, and so are you. Your body replaces roughly 98% of its atoms every year. The atoms in your stomach lining are swapped out every few days. Your skin, every 2 to 3 weeks. Even your skeleton is entirely replaced about every 10 years. The you that existed a decade ago and the you that exists now share almost no physical material in common. So when we talk about cremation, we are talking about what happens when this pattern, this wave, stops. And the atoms, which were always just passing through, are finally released from the shape they were temporarily holding. The question is, released into what? Part 2. The fire begins. A modern cremation chamber, called a retort, operates at temperatures between 1400 and 1800 degrees Fahrenheit. That's roughly 760 to 980 degrees Celsius. For context, wood burns at around 600 degrees Fahrenheit. Steel melts at about 2500. So we are talking about a serious, sustained heat well above what it takes to combust organic material, but nowhere near what it takes to affect the atoms themselves. And this is the first, most important thing to understand. Fire does not destroy atoms. I'll say that again, because it matters. Fire does not destroy atoms. Nothing you will ever encounter in everyday life destroys atoms. Not fire, not acid, not explosions, not crushing, not any force on the human scale. To actually break apart an atom, to split its nucleus, you need conditions found in nuclear reactors, particle accelerators, or the cores of stars. Temperatures of millions of degrees, pressures that would crush a mountain into a marble. A cremation furnace doesn't come anywhere close. It's not even in the same universe of energy. So what is the fire doing? It's rearranging. This is Feynman's great insight, the one embedded in that single sentence he said should survive the destruction of all other knowledge. Atoms attract each other at certain distances and repel at others. They form bonds. They build structures, molecules, proteins, cells, organs, bodies. What fire does is break those bonds. It provides enough energy to shake the atoms loose from their current molecular partnerships and allows them to find new ones. That's all combustion is. A rearrangement of atomic relationships. When you burn a log in your fireplace, you are not destroying the wood. You are breaking the chemical bonds in the cellulose molecules, allowing the carbon atoms to bond with oxygen from the air, forming carbon dioxide. The hydrogen atoms bond with oxygen too, forming water vapor. The heat and light you see are the energy that was stored in those old bonds being released as the new, more stable bonds form. The atoms are all still there, every single one. They've just changed partners. And the exact same thing happens to a human body. Topper 3. The first minutes. Let's walk through it. Carefully, respectfully, but honestly, because the physics here is extraordinary. In the first few minutes of cremation, the heat attacks the most vulnerable structures first, and the most vulnerable thing in your body from a thermal standpoint is water. You are, as we said, roughly 60% water by mass. That's a lot of water, and water evaporates at 212 degrees Fahrenheit, well below the temperature of the cremation chamber. So the very first thing that happens is a massive release of steam. Your water molecules, each one a tight little triangle of 2 hydrogen atoms and 1 oxygen atom, break free from the tissues they were woven into and rise as vapor. They pour out of the chamber, mix with the surrounding air, and begin a journey that water has been taking on this planet for 4 billion years. Those water molecules will rise into the atmosphere. Some will drift into clouds. Some will fall as rain, perhaps into a river, perhaps onto a field of wheat, perhaps into the ocean. They will be drunk by animals, absorbed by trees, frozen into glaciers. They will become part of the water cycle that has been running unbroken since the earth was young. Here is something to sit with. The water molecules that were part of your body will, statistically, end up everywhere, given enough time. And we're talking centuries, not millennia. Your water molecules will be so thoroughly mixed into the global water supply that every glass of water anyone drinks will contain some of them. Not metaphorically, literally. This is a mathematical certainty, given the number of molecules in your body and the total volume of water on Earth. But we're only at the beginning. Part 4. Soft tissue and the great carbon release. As the temperature in the chamber rises and the water is driven off, the real chemical transformation begins. The soft tissues, your muscles, your organs, your skin, your fat, are all made primarily of carbon, hydrogen, oxygen, and nitrogen, arranged into extraordinarily complex molecules, proteins, lipids, carbohydrates, nucleic acids, the molecular machinery of life. At cremation temperatures, these molecules can't hold together. The thermal energy is simply too great. The bonds snap. And what happens next is a cascade of chemical reactions, the most dominant of which is oxidation, the combination of these freed atoms with the abundant oxygen being pumped into the chamber. The carbon atoms, and there are an enormous number of them because carbon is the backbone of every organic molecule in your body, combine with oxygen to form carbon dioxide. Siawang Khan, the same gas that you were breathing out 5 minutes before you died. The same gas that plants pull from the air and use to build their leaves and stems and fruit. This is where I want you to pause and really think about what's happening. The carbon atoms that made up your muscles, your heart, your brain, the physical substrate on which your thoughts and memories were written, they become carbon dioxide gas. They float up through the chimney. They enter the atmosphere. And from there, they become available to every photosynthetic organism on the planet. A tree in a park might absorb one of your carbon atoms and build it into a leaf. That leaf might be eaten by a caterpillar, which becomes a butterfly. A blade of grass in a field might take in another, and that grass might be eaten by a cow, which becomes milk, which becomes a child's breakfast. Your carbon atoms will be built into other living things. This is not poetry. This is not metaphor. This is chemistry. This is Feynman's physics. The atom cycle. They always have. Cremation is simply a faster version of what decomposition does over months and years. It returns the atoms to the pool from which all life draws. The nitrogen in your body follows a similar path. Nitrogen atoms, freed from the amino acids and nucleic acids they were part of, combine to form nitrogen gas, wine-methyl-alkane, or various nitrogen oxides. They enter the atmosphere, where they join the vast reservoir of nitrogen that makes up 78% of the air we breathe. Some of that nitrogen will eventually be captured by nitrogen-fixing bacteria in the soil and cycled back into living organisms. Some of the very nitrogen that was in your DNA will, in time, be in someone else's. The hydrogen, as we mentioned, largely departs as water vapor, but also as various other small molecules. It re-enters the water cycle, the same ancient loop. So in the first hour or so of cremation, the vast majority of your body, by mass, has been returned to the atmosphere as gases. Carbon dioxide, water vapor, nitrogen gas, small amounts of sulfur dioxide from the sulfur in your proteins, trace amounts of other gases. You have become air. 25. The bones, but not all of you. After the soft tissue has been consumed, what remains is your skeleton, and the skeleton tells a different atomic story. Bones are made of a mineral called hydroxyapatite, which is a crystalline structure of calcium, phosphorus, oxygen, and hydrogen. It's essentially a ceramic, a hard, heat-resistant mineral framework that gives your bones their rigidity and strength. At cremation temperatures, the organic components of bone, the collagen, the proteins that give bone its slight flexibility, are burned away just like the soft tissue. But the mineral matrix remains. It can't combust. There's nothing left to oxidize. What you're left with is a collection of calcium phosphate fragments, dry, chalite, white, and gray. These fragments are what get processed after cremation. They're mechanically ground into a finer powder, and that powder is what families receive in the urn. When people refer to ashes, they are mostly referring to calcium and phosphorus, the mineral remnants of bone. But here's what's remarkable. Those calcium atoms in the bone fragments, they too are ancient travelers. The calcium in your bones came from the food you ate, milk, vegetables, grains, and the calcium in that food came from the soil, and the calcium in the soil came from the weathering of rocks, and the calcium in those rocks was deposited hundreds of millions of years ago by the shells and skeletons of ancient sea creatures. And the calcium in those creatures came from the ocean, which got it from the erosion of even older rocks, which were formed from the dust cloud that coalesced to become our planet, which was assembled from the remnants of earlier stars. Your bones are made of stars that died before the sun was born, and if those cremated remains are scattered, on a mountainside, in a river, at sea, those calcium and phosphorus atoms re-enter the geological cycle. They dissolve into soil and water. They are taken up by plant roots. They become part of new bones, new shells, new teeth. The cycle does not end. It never has. It never will. At least, not until the stars themselves go dark. Part 6, 5 Mans to Pure Point. Now, I've told you what happens to the atoms. But I haven't yet told you what Feynman found most profound about all of this, and it's the part that I think changes everything. Feynman once gave a lecture. It's famous among physicists, where he said something so simple that it almost sounds trivial, until you sit with it for a while. He said, "The atoms of our body are not permanent. They are like a kind of flame. The thing that I call my individuality is only a pattern, a dance. The atoms come into my brain, dance a dance, and then go out. There are always new atoms, but always doing the same dance, remembering what the dance was yesterday. A dance. He didn't say you are your atoms. He said you are the dance your atoms do. The pattern, the organization, the information. And this is where the physics of cremation becomes something more than chemistry. Because the question it forces us to ask is, what was lost? The atoms weren't destroyed. We've established that. They are all accounted for. The carbon, the oxygen, the hydrogen, the nitrogen, the calcium, every single atom that was in your body at the moment of death still exists after cremation. Not a single one was unmade. They've just been rearranged and dispersed. So what vanished? The pattern vanished. The dance stopped. The specific arrangement of atoms that constituted you, your neural connections, your muscle fibers, your particular configuration of matter, that arrangement was dissolved. The information was lost to entropy. And this is what Feynman understood with such piercing clarity. The universe doesn't care about atoms. It has plenty of atoms. What's rare, what's precious, what's extraordinary is the arrangement. The fact that atoms can arrange themselves into something that feels, that thinks, that loves, that asks questions about its own existence, that is the miracle, not the atoms. The dance. Cremation doesn't destroy matter. It destroys a pattern, and that pattern was the most complex arrangement of matter in the known universe, a human being. Part 7. The Conservation Law and its Consolation. There's a law in physics so fundamental that it has never, in the entire history of science, been violated. It is one of the deepest truths we have ever uncovered about the universe. The law of conservation of energy. Energy cannot be created or destroyed. It can only change form. And because matter and energy are related, because, as Einstein showed us, matter is a form of energy captured and frozen into substance by the equation E equals mc squared, the atoms of your body carry energy that is as old as the universe itself. When the Big Bang occurred 13.8 billion years ago, a finite amount of energy came into existence. That amount has never changed, not by a single joule. Every star, every planet, every living thing, every thought, every emotion, all of it is just that original energy, endlessly reshuffled. The energy in your body right now was present at the birth of the universe. It has taken many forms. It was radiation, then plasma, then hydrogen gas, then starfire, then heavier elements forged in stellar cores, then dust, then rock, then ocean, then microbe, then fish, then forest, then animal, then for one brief and improbable moment, you. Cremation does not remove that energy from the universe. It transforms it. The heat of the cremation flame is, itself, energy that goes somewhere. It warms the air, the walls, the structure. The chemical energy in your molecular bonds is converted to thermal energy, to light, to kinetic energy of gas molecules. It dissipates, spreads, is absorbed, and is reused. Nothing is gone. Everything is transformed. Feynman once received a letter from a student who was struggling with grief. The student wanted to know if physics had anything to say about death. And Feynman, who had lost his first wife, Arlene, to tuberculosis when he was just 27, and who had carried that grief with him for the rest of his life, wrote back something that I think is one of the most beautiful things a physicist has ever said. He didn't use equations. He didn't cite theorems. He simply said that the energy, the atoms, the material of a person you love doesn't disappear. It returns to the vast, ancient, churning system of the universe, from which it came and to which it always belonged. And that there is, in that fact, a kind of consolation that religion and philosophy have always reached for, but that physics can actually prove. Your loved ones are not gone. They are redistributed. Part 8. The Thog ets the Gefch. Experiment. Let me give you a thought experiment that I think captures the full weight of what we've been discussing. Imagine you could tag every atom in a single human body, let's say your own, with a tiny invisible marker, a cosmic GPS tracker. And then, after cremation, you could follow every single one of those atoms forward through time. What would you see? In the first hours, you'd see a cloud, a warm, invisible cloud of gas, carbon dioxide, water vapor, nitrogen, rising from the crematorium chimney and dispersing into the atmosphere. Carried by wind currents, the cloud would spread. Within days, your atoms would be distributed across an entire region. Within weeks, across a hemisphere. Within a year or two, they would be spread across the entire planet. Your carbon atoms would be absorbed by plants on every continent. Some would be built into rice paddies in Southeast Asia, others into pine trees in Scandinavia, others into phytoplankton in the Pacific Ocean. Some of those phytoplankton would be eaten by krill, which would be eaten by whales. Your carbon atoms would swim inside the largest animals that have ever lived on Earth. Your water molecules would fall as rain in the Amazon. They would freeze into Antarctic ice. They would fill the wells of villages in sub-Saharan Africa. Children would drink water that contains molecules that were once part of you, and they would never know, and it wouldn't matter, because those molecules were never really yours to begin with. Your calcium atoms, if your remains were scattered, would dissolve into soil and water. They would be taken up by the roots of an oak tree, built into its wood, and stand for 300 years as part of a living tower of cellulose and lignin, shading park benches and catching autumn light. And here's the part that gets me every time I think about it. In about 100 years, your atoms would be so thoroughly mixed into the global system that they would be, statistically, everywhere. In every handful of soil, in every breath of air, in every drop of water, in every living thing. You would not be in one place. You would be in all places. And this is not speculation. This is arithmetic. The number of atoms in a human body is so large, and the Earth's systems mix so thoroughly over time, that the math is inescapable. You will be distributed into everything, in a very real, very physical, very literal sense, not metaphorical, not spiritual, not wishful. You become the world. Part 9. What Feynman would want you to understand. Richard Feynman was not a sentimental man, at least not publicly. He was famous for his irreverence, his humor, his refusal to tolerate fuzzy thinking. He played bongo drums. He picked locks at Los Alamos during the Manhattan Project for fun. He once got into an argument with a philosopher about whether a brick was an essential object and ended the conversation by dropping the brick on the philosopher's foot. But beneath that playful exterior was a man who thought more deeply about the nature of matter, energy, and existence than almost anyone in the 20th century. And the thing he kept coming back to, the thing he clearly found endlessly fascinating, was the atomic nature of reality. He once described looking at a flower and seeing not just beauty, but a story. He could see in his mind's eye the atoms that the flower had gathered from the soil and air. He could trace those atoms back to the rain that delivered them, to the ocean that evaporated to form the clouds, to the sun that powered the evaporation. He could follow the chain all the way back to the nuclear fusion reactions in the sun's core, where hydrogen atoms were being crushed into helium, releasing the light that, 8 minutes later, would fall on a leaf and power the assembly of a petal. He didn't think this diminished the flower. He thought it amplified it infinitely. I can appreciate the beauty of a flower, he said, and at the same time I see much more. I can imagine the cells, the complicated actions inside which also have a beauty. There's beauty not just at the dimension of 1 centimeter. There's also beauty at smaller dimensions. And this is what he would want you to understand about cremation. When a body is cremated, the superficial story, the human story, ends. The person is gone. Their consciousness, their personality, their voice, their laugh. These are patterns that require a very specific arrangement of matter to exist, and that arrangement has been undone. But the deeper story, the atomic story, the Feynman story, doesn't end. It can't. The atoms are indestructible on any human scale. They go on. They join other patterns. They become part of other dances. They have been doing this for 13.8 billion years, and they will keep doing it for trillions more. You are not an object. You are a process, a verb, not a noun, a pattern that the universe is doing for a while, and then will do differently. Part 10. The most beautificant sense. I want to leave you with something. A fact that I think is the most beautiful thing physics has ever revealed to us, and one that ties together everything we've discussed today. Every atom in the universe has a quantum mechanical property called a wave function. This wave function describes, among other things, the probability of where the atom might be at any given moment. And here's the stunning truth. The wave functions of the atoms that were once part of your body never truly go to zero anywhere in the observable universe. They spread, they attenuate, they become vanishingly small, but they never fully disappear. In the most rigorous interpretation of quantum mechanics, the atoms that were once part of you maintain an incomprehensibly faint but mathematically real connection to every point in space. They are, in the language of physics, delocalized. They are here, there, and everywhere, to varying degrees of probability. Now this is an extremely subtle point, and I don't want to oversell it into mysticism. The practical effect is zero. You can't detect a single atom's wave function spread across the universe, but the principle matters, because it means that the universe, at its deepest level, does not recognize the hard boundaries we draw between things, between you and the air, between a body and the earth, between the living and the dead. The boundaries are emergent. They are patterns. They are, as Feynman would say, dances, and when the music changes, the dance changes with it, but the dancers, the atoms, continue on. So here is what really happens to your atoms in cremation. Nothing. Nothing happens to them. They are released from a pattern, and they return to the world to join new patterns. They are scattered into the atmosphere, the soil, the water, the bodies of other living things. They continue the journey they have been on since the first moments after the Big Bang. They are not diminished, not damaged, not altered in any fundamental way. They are the same atoms they always were. What ends is the arrangement. What ends is the dance. What ends is you, in the specific, local, embodied sense of the word. But the matter, the energy, the fundamental stuff, it was never born, and so it can never die. Closing, Richard Feynman died on February 15, 1988. His last words, reportedly, were, "I'd hate to die twice. It's so boring." Even at the end, he was irreverent. Even at the end, he was irreverent. Even at the end, he was thinking about the nature of experience. His atoms, the carbon, the oxygen, the nitrogen, the calcium, the iron, have been out there for almost 40 years now. They've been cycling through the atmosphere, the soil, the oceans. Statistically, some of them are in you. Right now, as you listen to this, some fragment of the physical matter that once constituted one of the greatest minds in human history is probably part of a tree somewhere, or a cloud, or a child who has never heard his name. And here's the thing, your atoms will do the same, whether you're cremated, buried, or anything else. The timeline changes, but the destination is identical. You will be returned to the system. You will be recycled. You will become part of everything. The next time you look at a fire, a candle, a campfire, a sunset that looks like the sky is burning, I want you to think about what fire actually is. It's not destruction. It's transformation. It's atoms changing partners. It's energy shifting form. It's the universe rearranging itself as it always has, as it always will. And I want you to think about what Feynman told us. In that one sentence, he wanted to survive the end of civilization. All things are made of atoms. All things, including you, including everyone you've ever loved, including everyone who has ever lived and everyone who ever will. The same atoms, the same ancient, indestructible, endlessly recycled atoms, dancing new dances, telling new stories, being borrowed by new patterns that will, for a brief and beautiful moment, look up at the stars and wonder where they came from. Now you know. They came from everything, and to everything they will return. If this changed the way you think about what you're made of, about what it means to exist in a universe that wastes nothing, then sit with that for a while and come back. Because there are more questions like this one. Questions that hide inside the ordinary and, when you look closely enough, shatter everything you thought you understood.